The next algebraic topic I'm going to cover are system of equations. So, what is a system of equations? So, a system of equations is actually two different equations that you need to solve. And typically, they are made up of two variables. There are some that could be made up of three, but for this tutorial, we're briefly going over just the two equations one. So, this is a quick example of a system of equations. So, we'll have one expression, x minus y equals 3, and another expression, x times y equals 4. And to solve it, there are two standard ways that most algebra teachers are going to teach. So the first one is called substitution. So how you substitute for a variable is actually by solving one of the equations, quote unquote, by separating the variable. So what you're going to do after you solve it is plug the solved variable into the equation. Of course, the variable isn't actually solved because we don't know the actual number, which we will find at the end, but it's just a placeholder for the other variable, which we'll plug into the equation. I'll show you in this example. So we have our first equation, 42x minus y equals 6, and our second equation, y minus 27x equals 24. So we only need to solve for one of the variables in one of these equations to be able to substitute. And just like in solving equations, we're going to want to do that by adding, subtracting, multiplying, or dividing. And the first thing you want to do is identify which variable you want to solve for. So, of course, in these two, x has a pretty big coefficient of 42 and 27, and that will just lead to more steps in solving because you're going to need to divide and get x on the other side, whereas y doesn't have a coefficient. Now, you could solve for either one, it does not matter. But we're going to solve in this case for this one, since the only step we'll need to do is just add 27x to the other side to solve for y. So that's what we did. We added 27x to this side, to the 24, and solve for y. So now y equals, from this equation, 27x plus 24. And what we're going to do with this y value is plug it into the other equation that we did not substitute in. So to do this, we're just simply replacing y with our expression that y equals that we got from the other equation that will have the other variable in it. So now, plugging into the first one, we still have that 42x from the first one, and we're subtracting from y. Since y is being subtracted, we actually subtract both parts of the expression because technically it's being distributed here. So we'll end up with 42x minus 27x here and minus 24, and that will equal 6 that we have from the first equation. And now we just have to solve for x like we did in solving equations. So you could combine this variable because it's being subtracted, giving us 42 minus 27x, which will be 15x, and we still have our minus 24 and 6. And now we just solve for x. So we add 24 to this side, get 30. 15x equals 30, x equals 2, and that will be our solution for x. And now we can go back and plug the solution for x, 2, into either one of these equations. So typically you want to do it in both to make sure that you are correct. So first we'll do it here. 42 times 2 equals 84, minus y equals 6. So we're going to subtract 84 from this side and get a negative number. It is negative 78. And then since they're both negative, we could just divide by negative 1, which will make it positive. So y equals 78. And then, like I said, it'll be better to plug it in to both equations. Well, now we could plug our solution to y and x into the other equation to make sure that we're correct. So we have y equals 78 and x is 2. 27 times 2 is 54. And then we'll have that 78 minus 54, and that will bring us 24. So we know that we are correct.